we want to find in terms of the vectors a and b, which we can see on the diagram, a being a vector that goes from O to A, and b being a vector that goes from O to B, the vector BA. We did this in the last example as well, but it's a start point for this example, which is quite long and involved. BA is the vector that goes from B to A. An alternative route is to go from B to O and then from O to A. This is an equivalent journey since the start point and end point are the same. B to O is backwards along B and therefore is minus B. O to A is forwards along A, or we could write this as A minus B. To go from E to B, we can see going from E to O is B, and then O to B is also B, so this is 2B. Now let's consider CA. We could go via B. So our equivalent journey is that CA is equal to CB plus BA. Look at C to B. This is the same as going from O to A. So CB is A. BA is the answer to part A, which is A minus B. So we have 2A minus B. We're now told that X is the midpoint of EF. We can see it on the diagram here. To go from A to X, we could go from A to F, and then we could go from F to X. This is the same as going from A to F, and then halfway from F to E. Halfway, since X is the midpoint of EF. Going from A to F is the same as going from B to O, so it's minus B. Going from F to E is the same as going from A to O, which is minus A, and we're going halfway, so we get minus a half A. To go from O to X, we can use a result that we've just found. To go from O to X, we can go from O to A, and then use AX. So our journey is from O to A, and then from A to X. OA, we can see from the diagram, is A, and AX is minus B minus a half A from part D above. So we get a half A minus B.